Good afternoon all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on Discrete Fourier Transform. Decimation in time, Fast Fourier Transform. Problem. First, conversion from time domain to frequency domain is slow. Cannot able to apply for vast applications. Filtering of the signals is also a slow process in DFT. That's why we are going for Fast Fourier Transform. Method DTFT, Discrete Time Fourier Transform, DFT, Discrete Fourier Transform, and then FFT, Fast Fourier Transform. What is mean by Fast Fourier Transform? A fast Fourier Transform is a family of algorithms that calculates efficiently the discrete Fourier Transform. The DFT is also a sequence x of k. The efficiency of the FFT is at the maximum when the length of the sequence is a power of 2. N is equal to 2 per p when p is a positive integer. The complexity of FFT algorithms is order of n into log 2 of n. This is the fast Fourier transform from the time domain sequence s of t, while we applying the Fourier transform of the time domain sequence which produces the frequency domain sequence, that is nothing but s of omega. While applying in terms of time domain, that can be converted into frequency domain with the help of fast Fourier transform. Next one, methods of FFT, DIT, decimation in time fast Fourier transform, DIF, decimation in frequency fast Fourier transform. This is the Radix-2 DIT FFT. Radix-2 means A and B can be given. Therefore, capital A is equal to A plus B. Capital B is equal to A minus B into W n into R. This is the Radix-2 DIT FFT. Next, this is the DIT flow graph. From the first we can going to calculate the 2-point DFT. From the results of 2-point DFT we can going to calculate 4-point DFT. From the results of 4-point DFT we can going to calculate 8-point DFT. The input must be in your bit reversal order, output must be in your normal order. There are 4 2-point DFT available. We can combine the 2-point DFT, we can compute 4-point DFT. Is it clear? We can combine 2 4-point DFT, we can going to calculate 1 8-point DFT. This is the decimation in time flow graph. 4-point decimation in time FFT. This is your first we can going to calculate 2-point DFT. From the results of 2-point DFT we can going to calculate 4-point DFT. The input must be in your bit reversal order. Output must be in your normal order. X of 0, X of 2, X of 1, X of 3. 0, 1, 2, 3. This is the 4-point decimation in time FFT. 8-point decimation in time FFT is nothing but first we can going to calculate 2-point FFT, and then from the results of 2-point FFT we can going to calculate 4-point DFT, and from the results of 4-point DFT we can going to calculate 8-point DFT. The input must be in your bit reversal order, output must be in your normal order. This is the butterfly structure of decimation in time fast Fourier transform. This is the input sequence order, original order 0 to 7. In terms of binary form 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1. Revised form is equal to 0, 4, 2, 6, 1, 5, 3, 7. This is the binary form of reversed order. Next one, what are all the multiplications and additions involved in Radix-2 DIT FFT? Each inner product required n complex multiplications. There are n inner products. We required n square multiplications. Right? There are 2n minus 1 such instances. Therefore, number of complex multiplications is nothing but n square minus 2n plus 1, that is n minus 1 the whole square. Right? Next one, complex additions is nothing but each inner product required n minus 1 complex additions. There are n inner products required n into n minus 1 complex additions. Therefore, n number of complex multiplications is n minus 1 the whole square. Number of complex additions is n into n minus 1. Right? Now we can give an x of n is equal to 1, 2, 3, 4. Find the x of k using 4-point DIT FFT algorithm. X of 0 is equal to 1, 2 is equal to 3, 1 is equal to 2, 3 is equal to 4. From the, we can going to calculate first results is nothing but 1 plus 3 which is equal to 4. 1 minus 3 is equal to minus 2. 2 plus 4, 6. Then 4 minus 2 minus 4 which is equal to minus 2. We can get the 4 minus 2, 6 minus 2. Now from the results of 2-point DFT we can going to calculate 4-point DFT. X of 0 is equal to 10. X of 1 is equal to real part plus imaginary part. Minus 2 plus 2j. X of 2 is equal to minus 2. X of 3 is equal to minus 2 minus 2j. Similarly for 8-point. Given x of n is equal to 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, you can find the output sequence by using DIT FFT algorithm. First, the input must be in your bit reversal order. We can get the first, we can going to calculate 2-point DFT. 4 minus 4, 8 minus 4, 6 minus 4, 10. We can get it as your 4. From the results of these 2-point DFT, we can going to calculate 4-point DFT. 4-point is nothing but 12 minus 4 plus 4j minus 4 minus 4 minus 4j. 16 minus 4 plus 4j minus 4 minus 4 minus 4j. From the results of 4-point DFT, we can going to compute 8-point DFT. X of 0 is equal to 28. X of 1 is equal to minus 4 plus 9.656j. X of 2 is equal to minus 4 plus 4j. X of 3 is equal to minus 4 plus 1.656j. X of 4 is equal to minus 4. X of 5 is equal to minus 4 minus 1.656j. X of 6 is equal to minus 4 minus 4j. X of 7 is equal to minus 4 minus 9.656j. We can going to calculate both real part and imaginary part. Now we can see the difference between direct computation and Radix-2 FFT. Direct computation required large number of computations. Radix-2 FFT algorithm required less number of computations. Processing time in direct computation is more. Processing time is less in Radix-2 FFT. Direct computation does not require splitting operation. It involves splitting operations as time domain basis and frequency domain basis. In direct computation, as the value of n DFT increases, the efficiency of direct computation decreases. Radix-2 FFT, as the values of n in DFT increases, the efficiency of FFT algorithm also increases. Now we can see the assessment. What is mean by FFT? Fast Fourier Transform. Why we are going for Fast Fourier Transform? To reduce the number of calculations. List the methods of FFT. DIT, decimation in time FFT, decimation in frequency FFT. In Fast Fourier Transform, time domain can be converted into frequency domain. In decimation in time, the flow graph is represented by 2-point, 4-point and 8-point FFT. What is the difference between direct computation and Radix-2 FFT? Direct computations required large number of computations. FFT computation requires less number of computations. Processing time is more in direct computation. In Radix-2 FFT, processing time is less. Direct computation does not require a splitting operation. Radix-2 FFT, splitting operation can be done on time domain basis and frequency domain basis. Determine DIT of x of n is equal to 1, 2, 3, 4. We can get the output sequence as x of k is equal to 10, minus 2 plus 2j, minus 2, minus 2, minus 2j. In Fast Fourier Transform, number of complex multiplication is n minus 1 the whole square. Number of complex addition is n into n minus 1. Thank you.